lecture on the subject name System Analysis and Design. And today's session is on strategies for good system design. So it is very much important for the concept of design while you developing some applications. Okay, so because it is as like that, the analysis phase is also important. It is just like the pillar. So the software design, basically the process to conceptualize the software requirements into software implementation. So this takes the user requirement as challenges and tries to find out optimum solution. So first of all, a plan is checked out to find the best possible design for the implementation, the intended solution. So there are multiple variants of system design. The first one is the structured design. Structured design is conceptualization of a problem into several well-organized elements of solution. Here the word well organized is important. So it is basically concerned with the solution design. This benefits of structured design is it gives a better understanding of how the problem is being solved. So structured design also makes it simpler for designer to concentrate on the problem more accurately. So there are basically two modules like cohesion and coupling. In cohesion, a group of all functionally related elements, whereas the coupling means communication between different modules. So these are the modules which are arranged as per their hierarchies. Okay. So a good structured design has high cohesion and low coupling arrangements. Then another thing is the function oriented design. In this design, the system is comprised of many smaller substances which is known as functions. So these functions are capable of performing significant tasks in the system, and the system is considered as top view of all functions. So this function oriented design inherits some properties of structured design where divide and conquer methodology is used. Okay, so this design mechanism is divided the whole system into smaller functions. Like if we are creating a big applications, then different modules we are dividing, and after completing all the modules, we have to integrate all those modules and then compile it into one, and then we compile it as an, you can say, a package. Okay, so the final result, like is the final output is a package you developed. Okay, so the another characteristics of function is that when a program calls a function, the function changes the state of the program, and which sometimes is not acceptable by the other modules. So function oriented design works well where the system state does not matter and program functions work on input rather than the state, because these all are actually interconnected, or you can say correlated. So somehow in many situations, or you can say in many cases, there are some linkage problem while we integrated those modules, so it might create a problem. So here system state matters. Okay, so the next is the design phase. In this, the whole system is seen as how data flows in the system by means of data flow diagram. So you have heard about DFD, data flow diagram. I have already discussed in my previous videos also. So the entire system is logically broken down into smaller units, which is known as functions, on the basis of their operations in the system. So each function is then described at large. Now come to the object-oriented design. This object-oriented design works around the entities and characteristics instead of functions involved in the software design. So this design strategies focus on entities and its characteristics. So the whole concept of software solution resolves around the engaged entities. Okay, so in a table there are entities, there are attributes, you have heard about all these. Okay, so the first, the important concept is the object. Object means what? All the entities involved in the solution design is known as object. For example, it should be a person, banks, companies and customers. So the next is the classes, and the classes means a class is generalized description of an object. So an object is an instance of a class, and this class defines all the attributes which an object can have, and methods which defines the functionality of the object. So in the solution design, attributes are stored as variables and functionalities which are defined by means of methods or procedures. And the first is in this it is encapsulation, inheritance and the polymorphism. So in encapsulation, you have also learned in C++ also. So in encapsulation, like the attributes and methods are bundled together is called encapsulation. So the next is the inheritance. It means OD allows similar classes to stack up in hierarchical manner, where the lower or subclasses can import, implement and reuse allowed variables and methods from their immediate superclasses. So this property of OID is known as inheritance, and this makes it easier to define specific classes and to create generalized classes for specific ones. The third one is the polymorphism. In polymorphism, there is a mechanism where methods performing similar tasks but vary in arguments, and this can be assigned same name, and this is called polymorphism, which allows a single interface performing tasks for different types. It is depending upon how the function is invoked, respective portions of the code gets executed. Now come to the design process. The design process can be perceived as series of well-defined steps, and though it vary according to design approach. There are many steps which is involved, like a solution design is created from requirements or previous use system and a system sequence diagram. Another is the objects are defined and grouped into classes on half of similarity in attributes characteristics. Then classes hierarchies and relations among them is defined, and the application framework is defined. Now come to the software design approach. There are two generic approaches of software design, top down and bottom up. Top down means this design takes the whole software system as an entity and then decompose it to achieve more than one subsistence or component which is based on some characteristics, and each subsystem or component is then treated as a system and decomposed further. So this process keeps on running until the lowest level of the system in the top down hierarchy is achieved. Whereas if we are talking about the bottom up design, this strategy is more suitable when a system needs to be created from some existing system where the basic primitives can be used in the newer system. So both top down and bottom up approaches are not practically individually, but instead a good combination of both is used. So this is all about today's session. Thank you. This session powered by Digital Version 2.0, Jayoti Vidyapeeth Women's University. Hope you are satisfied with my digital session. If you have any query, please mention in comment box. I will resolve it. Thank you.